Hi, today we're going to be doing a brief introduction into our first chapter in General Organic and Biological Chemistry for Nursing and Allied Health Sciences. We're going to be discussing a little bit about matter and measurements, how do we classify them. In this video, we're just going to be focusing on matter. In our next part, we're going to be focusing a little bit more on measurements. When we come down to it, chemistry is known as the central science. It tends to borrow from physics and biology, works together, simply because of the definition of what is chemistry. Chemistry is the study of matter. Everything that is matter, everything that has mass, takes up volume, is chemistry. We look at what's it made of, what properties we have, how can we change those properties, transform them into something that is convenient for us. So long as you're studying anything that has mass and takes up volume, you're doing chemistry. Usually, we classify our chemistry into natural products chemistry, which is basically anything that you can take from nature without having to do any type of, transformation. And then we have synthetic materials, our plastics, our polymers, our pharmaceutical compounds, medicines, some foods, soft drinks, like the example we have here. Those are all synthetic materials, simply because we can't find them in nature. Matter is usually found in one of three states in nature. The first one is the solid state. Think of chair you're sitting on, your computer, things of that nature. Those are solids. And they are defined by the fact that they have a definitive volume and a definitive shape. If they can't change the shape or the volume, then you're dealing with a solid. At the molecular level, everything that makes up a solid contains a regular pattern, tight molecules put together, bound, so they're not going anywhere, they're just vibrating there in position. When we look at a liquid, on the other hand, liquids have a definitive volume, they're not going to expand, but their shape can change depending on the container in which you put them on. Think of a glass of water, depending on the cup that you're using, the water's going to take different shapes, for instance. If you look at the molecular level, right, we look at all those molecules, they are tight, they're bound, they're close together, but the bounds are more or less suggestions more than actual bonds. They have something called intermolecular forces, so they're very loose and they can move around in the volume given in that liquid. A gas, on the other hand, has neither definitive shape nor definitive volume. It will expand to whatever container that gas is on. So if I have a can of a gas, the gas will take the shape of the can. If I open the can, it will take the shape of the room, etc., etc. Gas molecules are very far apart from one another, so they're not going to interact at all. That's one of the things that make gases different from liquids and solids. Also, they move around randomly. There are some things we can use to describe our different components, not only whether they're solid, liquid, or gases, but also what we call physical and chemical properties. When we look at a physical property, it's something that we can observe, that we can measure, without having to alter the material at all. So for instance, if I want to look at how much heat it takes for a liquid to boil, we can look at the boiling point, and can look at the melting point of a solid, for instance. If I want to differentiate between metals, for example, I can look at different salts or sugars or different solids to see if they dissolved in water or a different type of liquid, color, odor, just all these properties that you can think of that don't require having to alter your sample, whatever it is that you're studying, that's going to be defined as a physical property. Physical changes are changes that you can have in your material without having to necessarily alter the material itself. If we look at a classical example, water, you can turn water from liquid into solid form by just freezing it to 0 degrees or below. You turn it from liquid to solid, you did not change the nature of the material, you can melt it back down to water. You can also boil it into steam, and you will still have those two hydrogen atoms with that oxygen atom. That's just an example of what we consider a physical change. Chemical changes, on the other hand, involve transformations, involve chemical reactions. That's one of the main things that we're going to be covering in later chapters. For now, I want you to know that a chemical property is something that we can use to determine whether something will react or not. For instance, whether it's acidic or alkaline, whether it's corrosive, whether it's flammable, volatile, things of this nature will be considered chemical properties and will be used to further transform these compounds into something that we may find useful. Chemical changes differentiate from physical changes in the fact that, as I mentioned before, involves a transformation. Think of a bar of iron getting rusted, turning to iron oxide. That's a chemical change because you can't turn it back into iron. If you, let's say you burn paper, you're turning the cellulose into carbon dioxide, into water, into ash. You can't turn it back. So that's usually a pretty good rule of thumb for determining whether something is a chemical change or a physical change. Another way that we classify matter is in whether it is a pure substance or part of a mixture. Mixtures don't necessarily have to be homogeneous. They can be heterogeneous. They can be different things. We'll get to that in a bit. Pure substance, on the other hand, which is what we're going to consider first, is when you find something made up of just one type of substance. Now, that type of substance can be an element or it can be a compound. It can be more than one atom, one type of atom, so long as it's one of the same, it's uniform all throughout. It's going to have a constant composition, regardless of whether you're looking at a few molecules or a few kilograms of the sample. You're going to find the same exact composition. Not only that, but when you have a pure substance, again, it doesn't have to be an atom, it can be a molecule, but you can't break it down, you can't simplify it further by physical means. A few examples here. Let's say you have like the bar of iron that I mentioned before earlier. That's just one type of atom, so that's going to be a pure substance. Here, for instance, we have two pure substances that are what we call compounds. They're made up of more than one type of atom, but they're uniform all throughout. If you look at water, water is H2O, we have it right here, and it's going to be H2O no matter if you have a drop of water or a gallon of water. The same is true for table sugar, table salt. It's just another example. Doesn't matter if you have a tablespoon or a truckload of sugar, sugar will still have the same chemical formula, making it a pure substance. Mixtures, on the other hand, are a little bit easier to spot because you can separate them by physical means. They have more than one component and they have different compositions. Think of a cup of tea or a cup of coffee, for example. Coffee grounds are made up of a bunch of different molecules, and when we pour hot water through it, we're able to extract a few of those compounds which make up the coffee that we so much like to drink, or for me at least. We have various methods of separating compounds. Here we have something that we call distillation for separating liquid mixtures, and we have here chromatography. And as you can see, the different substances have different colors, as you can see in the sample right here. That's pretty much the main difference between a pure substance and a mixture. Another way to look at mixtures, you have your saline solutions, for example. You have salt dissolved in water. Those are more than one component. That would be what we call a homogeneous mixture. We have sugar in water here as well, simply because in the case of sugar or salt in water, you can't just point at a certain place in the glass and say that part is sugar or that part is water. It's uniform throughout, so I will make it a homogeneous mixture. Another way to classify our pure substances is between elements and compounds. Think of the periodic table. If you can find the entire substance in the periodic table, then you're probably looking at an element. That's pretty much what we have. When we have compounds, we have more than one type of element in that pure substance. We already saw a few of those compounds that make up pure substances. We saw water, we saw sodium chloride, we saw table sugar. All of those are pure substances, but we classify them as compounds. And here we have, just to finish up this part of the presentation, a quick summary of how we classify matter. If we can separate the different components by any physical process, then we're dealing with a mixture. If we can't, then it's going to be a pure substance. Pure substances can be further broken down into compounds or elements, depending if I can separate them by chemical means or if I can't. And that's pretty much it. That's how we classify matter. Pure substances, mixtures, and in pure substances we have elements and we have compounds.